Now we're going to go ahead and use a Terraform Provisioner so we can run a script after any given instance is created. So the first thing I want to do is actually change the instance count to 1. The next thing that I want to do is update my variables so that I have a private key path, so SSH private key path, and this will just get rid of our .pub there and our private key path. And then our type, or rather whether or not it's going to be sensitive, this value will be true. So with this in mind, what I can do then is I can actually use the Linode resource, the instance resource. I can do something called provisioners. So a provisioner, and it's called remote execute or remote exec. We can actually run various commands in here. So the way we do this is with SSH. So we can go ahead and say our connection. We set a connection, and then we set an inline list of things that we might want to run. We'll figure out the connection in just a moment. But to start, what is it that we're trying to do here? I'm just going to go ahead and install Docker. So I'll do sudo apt-get update, and then I'll go ahead and do curl-f https://get.docker.com with a pipe sudo su. And actually we'll do FSL like that. Okay, great. So this will be our script that we're going to go ahead and run. Now this is going to be just like on SSH. So you could do the same thing with just simply SSH. But of course, this is going to go based off of the number of counts. It's going to happen each time this is connected. So what are the connection parameters? First off is host, no surprise there. Next up is going to be our type of SSH. The user we can just declare as root because that's the default for Ubuntu on Linode. And then we're going to go ahead and add in our actual private key, which is why I went and go ahead and did our file var.ssh private key path. Right? So in this case, I can actually just open up that file and it should work just fine, just like this. So you definitely need that private key, and it has to correspond to this public key that we are installing. So this is where if you were to change them, you would want to be aware of that and make sure you're passing both of the changes into the TF vars. Now you only change them when they first start. You don't change them later, otherwise it's going to recycle your entire thing, which maybe that's what you want. So of course, the next thing is our host here. What host value do we need? Well, if you remember back to what we were doing when we were trying to get an instance, I'll go ahead and leave this as an empty string for a moment. But when we actually tried to get an IP address for something, we did the instance.web, then .ip address, right? That's done in our output here. And of course, it's indexed, so there's a specific value, but when there's only one, as in no count whatsoever, this was how we did it. Now we can actually reference this whole thing by using a keyword that's reserved as self. So self.ip address is how all of that's going to end up working. And so what this hopefully tells you, or should tell you, is that that IP address will only be available once everything is provisioned, just like the output itself. So even if that's not very obvious just yet, that's exactly what's happening. That means that this provisioner happens right after it's been provisioned, right after the instance is available, so that it can run that connection. Now, this is really useful for doing all kinds of just really quick configuration. But what it's not doing is it's not verifying that Docker's already there. It's not verifying if it's running. It's not verifying if it's failed or anything like that. It's really just going to run these commands and that's it. So let's go ahead and try this out. We'll save it and we'll do Terraform and I'll go ahead and run plan. And this time we should get a refreshed state. It's destroying 2. Notice it's not actually running anything. Uh-oh, why not? Well, I ran or added this provisioner after it was already provisioned, after it was already there. These provisioners aren't drastic and they won't automatically change everything. So if I wanted to change something, I would have to actually go about changing everything about this instance, or I could just go back to being something like 0, and then we can run that apply now, and I'll just go ahead and auto approve it. And that's going to take down all of those instances. or at least it should. Yeah, so we got an empty tuple here for this because we don't actually have any. So we've got a little problem with our output on main.tf, which we will come back to in just a moment. But now that we've got that, let's go ahead and get rid of that commented out. It's going to take everything down for us, and it's just going to take a moment for that to happen. And so once everything's back up, then we'll be able to actually run this provisioner, which actually will make the entire provisioning, the end-to-end provisioning, take quite a bit longer. So let's take a look at what that looks like after this is done. Okay, so all resources have been destroyed. Let's bring this back up to 1 now, and I'll just go ahead and apply it again. So now, with it applied, as well as my output being back, because I applied it, it's going to take quite a bit longer because of just running the Docker installation command, right? And so what you would do instead of using these provisioners, this is where you'd use something like Ansible or Salt to just provision your instances themselves. Because at this point, all we've really been looking at are Linode instances, the actual web instance. But if you toyed around inside of the registry at all, you would see there's a lot of other resources out there that, in some cases you might be able to use a provisioner on, but in a lot of cases it won't need additional provisioning because it will just be ready. A good example of that would be a managed database or a managed Kubernetes cluster. Those things come to you and you're able to use them. But what we see here now is this remote exec or the remote execution, and it's actually running off of that host with the root user, not using the password, but rather using the SSH keys. It's not also going to check anything. It's not doing the host key checking, but it's going to go ahead and run that and just do the installation as it sees fit. And so we'll let that finish, and then we'll come back. We'll actually log in and verify whether or not Docker was installed with SSH. Okay, everything was successful, and it looks like Docker is able to run. Looks like it's in there. So let's go ahead and verify this by just SSHing into that new instance. We'll go ahead and say yes to the authenticity, and then we'll Docker PS, and there we go. Docker is in there, and it's ready to roll. Now, I'm actually not going to run Docker right now. That's not really the point. The point of this was to just see how we can install various packages. So for configuration management, which is essentially what's happening here, Terraform's not really well suited for it, but it can do it, and it can do it in a way that is pretty logical. And if you had to do multiple provisioners on here, you could. In other words, you could do a whole nother one, and a whole nother one after that, and a whole nother one after that, if you needed to have multiple steps for that. And so it would complete the process each time, and then you'd be able to do any sort of inline commands that are happening here in terms of SSH type commands. But again, this is not the best way to do it, because right now, if I go to apply it again, it's not going to run that provisioner again. It's just done. Everything's done as far as Terraform is concerned. Whereas if you were using something like Ansible or Salt, you could run it again, or Puppet Bolt, you could run it again, and it would actually attempt to reconfigure it. It would literally check the state inside of that instance to make sure that what you want installed is installed and what you want running is running. But using provisioners can be nice and can be a useful thing. Now we're going to use a different provisioner called File, which will allow me to have a bash script in my project that then the provisioner can reference. And this will also introduce us to something called locals in Terraform. So what we're going to do here is we're going to create a new folder, and I'm going to just call this scripts. And inside of this folder, we're going to call it bootstrap-docker.sh. Okay. So regardless of what system you're on, this is what you're going to name it. And I'm just going to go ahead and copy and paste a script that I already created for this. But the idea being that it's almost identical to what we just had, just slightly different. And one of them being that git docker, the actual sudo command, is going to be after. It's not going to be all in one. That's on purpose. Okay, great. So now that we've got this file, I want to be able to use it as a provisioner. So I'm going to go ahead and comment out my remote execution provisioner. Instead, I'm going to go ahead and bring in my file provisioner. Okay. So to do this, we have to go ahead and say file. The connection is going to be the same. So I'll bring that up and uncomment it out. Right? And then the actual source is what we want next. And then the destination is the final requirement. Okay. So the destination is where we're going to store it on the instance itself, which I'm going to put it into the temporary folder and just do bootstrap-docker.sh. And then we need to find our source. So for this, I'm going to be using something a little bit different than variables, although it could be variables, but I'm going to use something called locals. So with locals, what we do is we are going to go ahead and say locals.tf. And then I'll go ahead and add in the locals argument. And in here, I can have a few constants that you might want to use. In my case, these are going to be file paths, but it could be anything. You could say count in here as well if you wanted to have a count being specific or more stable in terms of how it's end up working instead of being a variable. But of course, I'm not going to do that. Instead, what I want to do is declare the root directory first. So what's the root directory? Well, I mean the root directory to this exact folder where I have all of my Terraform files. Now to do that, we can actually use a built-in argument of path. So we can do $path.root. And of course, we can always verify this by going into the Terraform console and again, doing path.root. And that gives me this period here, which is not great. So there is another built-in function that we can use, and that's ABS, as in absolute, and then path.root. And what do you know? It actually gives me the absolute path to this Terraform module, regardless of where it exists in terms of your operating system. So if you move it around, it's going to move around with it. So in other words, we can go ahead and just say that this root directory is there. That's exactly where we want it. And so the next thing is, where is our script directory? So we can say scripts dir, and we can have it relative to the root directory. So to make it relative, of course, I could use absolute path.root and all that, or I can use local.root dir /scripts. And then with my scripts dir, I can also go ahead and say my bootstrap script path. And once again, I can use that scripts dir as local and then simply bootstrap-docker.sh. Okay, so with this in mind, let's go ahead and exit out of the console and just refresh that session and just simply do local.bootstrap script path. And what do you know? There's an absolute path to that script now. Now, the reason I like using locals for this versus variables is this is likely not going to change. And if it does change, I want it to be done through Git. I want to see that version control change happen. Now, this is a good time to really think about, should your public keys be variables or should they be locals? Now, if you were going to stick with just your workstation and these keys, then I would say keep them as locals. But I think the chances are really good that you should probably create specific SSH keys for Terraform to work with, and that's it. Not going off of the workstation, but specifically for Terraform. Now, that's outside the context of what we're doing here, but basically, I think of locals as something that shouldn't change very often. It's not really a variable that will change, but if it does change, we want to have version control of what ended up changing, right? So if that bootstrap Docker file was changed, we would know about it. That's kind of the idea, or at least that's how I treat locals. So with this in mind, I can go back into main.tf, and the source itself, we don't have to use file. We can quite literally just use local and bootstrap script file, and that's it. And so this should allow me to provision that file and bring it to this destination. So then what I want to do is use this provisioner again. I will go ahead and copy that original one. I'm going to uncomment it out. And what I want to do now is I'm going to go ahead and do chomod plus X of the destination file itself. And this, again, could also be a local path that we want to set. But in this case, I don't need to because I'm really only using it in two places here. So chomod plus X will allow me to execute this. And then we do sudo su and that temporary file. Now, granted, this is two steps to do the same thing as I did with one step. Two provisioners to do the same thing. So realistically, you probably aren't going to do it like this, right? You'll probably actually have it like I did before, where it's just one inline command because those were 2 lines and it was only one provisioner. But this main part is mostly to get that file. So if you needed to do additional installations, like in this case, I have Git being installed and I'm making sure that that's happening. This would be a way to make sure that the initial setup is going through. And once again, if I do Terraform and apply and do -auto approve, I'm going to get nothing. Nothing changes because I just added provisioners, and that's not a big enough change. So what we could do then is change it back to the count. The label wouldn't do it. We could also just change the version or even the location. So if I do USC, I think that region should work. Let's go ahead and give it a try. It might not work. If it's the incorrect region, it will not work for me, but changing the region absolutely will trigger an entire refresh here. And so I'll let that finish, assuming that everything works, and then we'll go ahead and do that SSH again to check that Docker is running once again. Oops, little typo. This should be not sudo su, but sudo sh to actually run the script itself. So go ahead and run that again if you had some errors. All right, so after doing that and maybe almost 3 minutes or so, it was able to provision everything. So if we go into login and do docker ps, we see that Docker's running once again. And that's, of course, what that script was doing itself. Now, one of the things that was really nice, if you did run the whole thing with sudo su, this incorrect command, this actually will cause you to reprovision things because the provisioner would fail. In other words, once you fix it and try to run it again, it's going to take down that old instance with that failed provisioner and then try with a brand new one, which I think is also really just a convenient feature to these provisioners and does give it some of that configuration management you might need from the get-go. So at this point, what I want to do is I actually want to prepare this project to be able to work with something like Ansible. We aren't going to actually configure the Ansible part. What we're going to do instead is we're going to configure a few resources that will then create a local file on this workstation that Ansible would end up being able to use, which will help us explore Terraform templates a lot so we can see how to output local files as a different kind of a resource. Templates are nice because they allow us to pass in various context objects to create a new file or some sort of new string. So let's go ahead and first off do our templates dir, and this is going to be basically the same thing as our scripts dir. So we'll go ahead and do templates, and then we're also going to go ahead and do our hello world template, and I'll just do tf and tpl. Okay, so that's Terraform template. That's the extension that it'll end up being. And of course, it's going to be our templates dir and then hello world.tf or tftpl, just like that. So let's go ahead and create this by adding a new folder in here called templates and then a new file called hello world tftmpl. Okay, great. So at the base level, we can go ahead and say hello and then some string substitution. Now, this is probably not that surprising as to what this could end up doing. So let's take a look with the Terraform and console. So we've got our template for this hello world. So we can do local.thattemplate. Of course, that is the path to it. So to render it out, we use something called template file and grab that path, which is the hello world one, the entire thing. So let's go ahead and do template file and local.hello-world. And then we also pass in a mapping here. So if it's an empty mapping, I get this error and it says the vars map does not contain the key name. So if you've ever used something like Django's templating engine or Genja or Shopify Liquid themes, it works a lot like that, where it's a lot like string substitution. And it also allows me for a little bit of programming logic that happens in here. So this actual dictionary that we want to pass is we want to pass in the values that are in there. So in this case, I'll just pass in name. And this time it actually gives me that string back out with that name coming through. But what I can also do is I can pass in something like items and equals to like, something like phone and maybe keyboard, right? And so if I hit enter now, those don't get rendered, so I want to render them. And to do that, we can use the for loop syntax, which is percent and then for loop data, so percent, and then it ends with a tilde. And then we can come in here and just say end for. So what does a for loop look like? Well, it's going to be for my variable in the argument itself, which in this case was items, right? So this my variable could be item, it could be ABC. This is literally a variable that changes within the for loop. It's very similar to those templating languages that I mentioned before. And so you can say for item in items, and just use that same string substitution in there. And now when I run this, I now see that it is a more robust file that has spaces and all of that on purpose, right? So we could actually render out this file to do something just slightly different than this. But this templating allows me to then manage, well, my resources, right? So if I have a bunch of resources that I want to know what those IP address is, sure, I can use this output that we've been using, or what would be better is I can actually output it to a specific file that something like Ansible could use, or I could just use it in other terms, in other senses, like I could email that file or something like that. But we're going to use it for something practical, which will be for Ansible's inventory file. But the idea being that using templates can be useful all across the board. And realistically, you could use the template in other places too. It's not just for, like you could use the output as part of the template, right? So if I came in here and did my output, let's go ahead and say VM SSH strings. This time I'm going to go ahead and duplicate this, and we'll go ahead and say my SSH connect, something like that, right? So SSH connect now is going to be my VMs. And so in this case, I'll do SSH root at, and we'll call this my, my instance. So we could just say instance.ip address now, something along those lines, and we'll take a look at what that does. So inside of my main.tf, and this time our value could be simply the template file itself. And then we need our path, which in our case, we'll use some string substitution here for local.templates_dir, which I believe is what we called it. Let's just verify that. So locals.templates_dir, right? And then after that, we would do /ssh-connect.tf-tpl. So that's one half of that template file function. The second half would be the VMs. So this is going to be, of course, equal to a list. Now, let's just verify that again, that's the argument that we put in here, or the context variable that's in here, and that's this right there. And so we want to make sure we're passing an iterable, which in our case, the iterable would be linode instance.web. So we can come in here and just say linode instance.web. So we can save that, and now we've got this output here. Let's go ahead and take a look at what that will do. So we'll do Terraform and plan. Let's just verify there's no errors here. And so we've got this errors, reducing the risk of this data coming out. Well, this is probably not great in the sense that I'm giving the entire instance itself. So perhaps I want to change this from VMs to IP addresses, and we will change that instead. So we'll come back into our connect here. I'll just change this to IP addresses, and then this just to IP address. Really simple change, but now we're not giving the entire context to that template itself because of this warning. It's saying that it might have sensitive data in there, and perhaps you want the argument to be true. And so the IP address itself may or may not be sensitive. But the thing is, right now, this is not a correct loop. So we need to turn it into a loop itself. And to do that, we're going to go ahead and use this here, and we'll say for, let's now say just something like for host in the instance.web itself, and we'll do .star to make sure we're getting all of them. So this is just getting all of the list items in there, and then we use this colon to just simply grab host.ip address, and this should be a string substitution value, just like that. So this is doing the same kind of loop, but now it's just in one location. It's all in one line. So if I save that and we run this again, this time I don't think that sensitive thing is going to show up, and sure enough, it does not. So let's go ahead and apply it, and we will see the various strings that are coming through in here, and I'll just go ahead and say yes. And there is my strings. That's the output right there. And of course, if I were to create a couple more items or a couple more instances, I can now see this template happening in two different ways, right? So one of them is just if I need a message, a one-off message, the other one being a lot more practical in terms of all of the different SSH values I might want to display inside of my outputs, right? By leveraging that template file. And of course, I could just go in and change that template file as I see fit. And you could also have other variables in here as well, like your default username and all that. But that's something I would let you play around with on your own. The the main thing here is we can now see that you can use these external files that you can just change rapidly to just have a better look or a different look as to the values themselves. Now, there's another key thing that's happening within this particular output and this particular output that we just never really discussed. And that's the fact that the Linode instances are happening and then the output happens, right? So Terraform does this really intelligently. If you start referencing other resources throughout, those resources will be created before something else happens. Like in this case, these output values are coming after that logically. But if I actually had these output values up here, this is not an error. This is completely fine, and you're still able to get that same data out, as you see we did here. Or you could also bring it into an entirely different module and call it outputs.tf, which is what I would recommend in the long run. And then there you go. Now you've got quite a bit of a different look at the outputs, but the same data, and also Terraform handles it very logically on how this happens, which also should indicate one more thing about these resources is Linode instance web has to be unique across your entire Terraform project. So that label right there does. This label right here, Terraform doesn't care about. That's a Linode thing. Linode makes sure that this label is happening and it has to be unique on your account. Terraform doesn't care about that label. It cares about this one, or the sub-label itself. So with this in mind, what we'll have is all three of those instances configured, and it took a few minutes to do so. But here are my 3 IP addresses that are for each one of those instances. And of course, if I go into my account, I would be able to verify those. So we got 95, 19, and 23, 95, 19, and 23, and in the same order based off of how I named it. So templates are really nice, and they're really, really useful. So let's take a look at one more version of this. But instead of having it output to my command line, like we did here, I can actually output it and manage it with a outputted file itself on my remote workstation. So we're going to do this by outputting the IP addresses from our Linode instance, the web one, with a certain number of count. I got rid of all of the provisioners just so it speeds things up a little bit. Next, of course, my Terraform instance, the actual count, I have it at 1 currently. So to use a local actual file, we actually declare a brand new resource called local file. In this case, I'll just go ahead and say web app or web IPs, something like that. We just want to give this a unique name across my Terraform project, just like any other resource. And so what we want here is content, and we want a file name itself. Okay. So the file name, I'll just go ahead and say local web-IPs, not APIs, but IPs.txt. The content itself is going to be based off of, well, our actual Linode instance. So what we want here is I'm going to go ahead and get the host names. So one of the things I could do right off the bat is something simple, is grabbing the 0th element here and do IP address, right? Or I can actually iterate through all this. And of course, the problem with this is something we've seen before with our outputs when we tried to make it 0. The same problem exists, and that is we need a condition here to make sure that it's outputting correctly. In other words, I'm going to go ahead and say length of this. If it's equal to 0, then I'll go ahead and say no IPs, and then I use a colon here for the other, right? So this maps directly to a lot of modern JavaScript where you have the condition here. If it is met, then it's going to do that value. If it's not met, it's going to fall back to something different. And this length will actually look at the list here and just see if it is 0 or not. And then it will do that accordingly. And so after declaring a new resource like this, what we'll need to do is terraform init-upgrade. And that doesn't matter if we added other resource providers or something like local file, which we don't actually need to put on here because it's not a third-party provider. It's a Terraform one, but it's one that we still add. Then, of course, we still need our backend config for that backend. Once you do that, it's going to update everything as needed, and it's going to install the local file resource as needed as well. So now what I can do is terraform and plan, and this time it should actually plan to add something. It's going to add a local file resource, which is just going to have the content of that IP address, as we saw right there. So let's go ahead and actually bring in that plan. So I'll do apply and auto approve. Okay, so that will create that local file right there. There it is. Pretty neat. So we can, of course, extend this a bit by updating the number of instances we have, going back into our local file resource, and instead of getting only one instance, we can use something called join. And we can join it by using /in, as in a new line. And the thing that we're going to join here is a list itself. So, of course, lists are like this, right? And one of the ways to do this inside of Terraform is to run a for loop. So we can say for host in the Linode instance .web.all. And so host here is arbitrary. It's just a variable. And we can set the values for each loop to being $host.ip address. And so what this is going to do is actually loop through all of that and join it together in one line-by-line string, which we can verify by going into the console itself and paste that in, and there it is. Granted, I did make a change to the variables, but if I don't have more than one, it's only going to be at 0. And of course, if it is at 0, it's just going to output no IPs. Great. So let's go ahead and apply this. So I'll do Terraform and apply, and then we'll go ahead and do auto approve again. And so while that's running, I want to make sure that this happens in other places that I use Linode Instance Web. So I'll go ahead and copy this, and we'll come into our outputs here. Our outputs, this is a good place where we will need them. And it's going to be just like this. So I'll go ahead and say no web IPs. Right? So basically, if there's no web IPs, that's what the value is going to be. Otherwise, it's going to go to whatever that fallback value is. Now, this is going to be great if you narrow this down to 0, which is actually what we'll do in the next part once we actually create this local IPs here. Right? So that's kind of the point, is to actually be able to manage a local file with the various resources that are coming through based off of our entire Terraform project. So the other part about these resources, like we have seen with our outputs, is the actual ordering or where we locate these things doesn't matter. If it's referencing another resource, it's going to wait for that resource to finish before it moves to this resource and updates that file with all these IPs. So we've actually now laid the foundation for what we want to do with the Ansible inventory file, which is going to be like my Ansible group, something like that. Spelled correctly. But the idea being we are now ready for that next step. The other thing here is, what if I accidentally deleted that TXT file? What I can do is just go ahead and apply it. Ansible will refresh it. It's going to go ahead and bring everything back up. I accidentally changed the variables. But it would refresh that file itself in here just to make sure that everything is done correctly for that file, at least for local file resources like that. So it does manage it really, really well. Now we're going to put it all together by creating an Ansible inventory file. Now, even if you're not familiar with what this file does in Ansible, which is sort of the point of the Ansible course, the file itself is the result of using Terraform in, I think, all of its glory. So let's take a look at how we're going to go about doing this. First and foremost, I want to just make sure that I don't have any of my web instances running in main, right? We just want to make sure that none of these are going because, well, we just don't need them anymore. That was really the working example. But we will still use this resource or something very similar to it. So I'm going to go ahead and create a new file in here, and we're going to call this the Ansible inventory.tf. Okay, so the reason I'm calling it Ansible inventory versus something else that's a little bit more generic to Terraform is so that I would be able to reuse this module in some form later. So let's take a look at that. First and foremost, I'm going to go ahead and grab this resource here. We're going to bring it in, and we're going to change it. So naturally, what I can't do because of Terraform is call it web. It has to be something different. It has to be a unique name here. So I'm going to call this my Ansible web apps. That's it. The count itself will still be a variable. So let's go ahead and declare a variable up here. This variable will be Ansible web apps count. Okay. I'm going to leave a no default in here, but I will add in the type equaling to a number. Okay, so I'll bring that in as the variable. The label itself should no longer be IaC Terraform, but really something like Ansible. Okay, and everything else, roughly the same. I could still use that same password or just have no password whatsoever because I still have those SSH keys in there, and that's what I'll have to use also for Ansible. Now, generally speaking, when you start to go to production, you're going to want to have different keys, as I mentioned before, but it's important to think about when you start integrating two different tools as well. But for now, I'll go ahead and leave the same, remote workstation system keys, and I'll just change the tags. Cool. So that's it. That's all I want to do here. And I didn't actually place the variable yet, so let's take a look at what happens when you don't set the variable. So if I do Terraform plan, I get this. It's prompting me for a number of web apps that I want. Now, the nice thing about this is the fact that I don't have a default in here, right? So if I put a default in, that prompt goes away. Or if I actually put the variable in to TF vars, then that prompt goes away as well. Just something to think about when you come to doing these things. So now if I do the plan, it says it's going to add 3 things. Great. So, of course, the next thing is to actually turn this web apps, get all of those IP addresses, and make it a local file resource. So if we do resource, local file, this again is going to be Ansible, but this time it's going to be inventory. Okay, so Ansible inventory. Now, once again, we have our content and then our file name. And for now, I'll just go ahead and do the inventory.ini in my local folder. So as we saw before, the default for this file will go into the directory you're working on for Terraform. Great. Now the content itself, well, it's going to be obviously all of the IP addresses here, and we need to loop through all of them. As you may remember, all of them are in the Linode instance dot, the label name that we gave it, or the sublabel, dot star. This will give me all of those items. And the reason I have it in a bracket is because I can loop through all of them. So for host in that information. And then the colon at the end of here, we can use some string substitution based off of this host. And it's going to be $host.ip address. Great. And what we saw before was this split thing here. We can use something similar to that called join. And instead of splitting it, we are going to join it. So basically, this will then be a list of IP addresses with no other format. If you needed a dash in there, you totally could do that. Okay, so this time, let's go ahead and plan it again. There we go. And I'll go ahead and run apply and auto approve. 4 things to add, makes sense. We've got our local file here, and then our inventory and all of that with our SSH keys for the actual workstation. So let's go ahead and run that. And I'll let that finish provisioning. And there we go. Looks like everything was created. We've got inventory.ini. And there we go. So this is almost an Ansible inventory file, but it's not quite there. So what we need in here is something called like a group. Now, this is all Ansible specific. So something like web app, for example, that's what we need in there. So if I were to run this again, what's going to happen is this web app should go away. And it does. So what we want to do then is create a new template for it, right? Similar to this hello world template in the sense that we want to iterate through things. Now we don't have to iterate through things. So I'm going to show you 2 different ways on how to do this Ansible inventory template. So once again, I'll call this Ansible inventory and .tfpl. Okay, so this makes it a little bit less modular. Like I can't just drop this file in any longer, but I will be using that template itself. Okay, so the idea here is we can absolutely pass this in as a variable that we use or like a context variable that we use inside of this template. So we can actually come in here and say IP addresses, something like that, and then add in the group itself. So let's go ahead and do that, and I'll call this web apps. Okay, so once again, inside of our TF file, we now need to grab the templates directory. And again, it's no longer going to be super reusable, but I will grab this templates directory and we'll go ahead and do template file. And I'm going to go ahead and bring it into a couple lines here. So the template file, it starts off with a path And that path is going to start off with local.templatesdir / Ansible inventory.tf. Oh, whoops, that should be tf-tpl, not just pl. So let's go ahead and change the extension on this one. Okay. And there we go. And then the next one, of course, is a map that we're going to pass in here. And this map, this join statement, we can go ahead and bring in. Let's go back into the template itself. It's going to be called IP addresses. So IP addresses equals to that. Okay. So let's go ahead and run this again. And this time our inventory file changes just slightly, but enough to be like, oh, okay, I see what's happening here. This is good. We want to be able to output that. Now, on one hand, maybe you do the join inside of the inventory file, or maybe you do the loop inside of the template, right? So whether it's in the resource file itself or in the template itself, completely up to you. So the way I think about this then is instead of joining everything, I would just come in here and change it to just being a list of items without that parentheses. And so now I've got IP addresses. And so the idea then would be in the template would be to iterate through those with a for loop for IP address in IP addresses, just like that. Okay, so computationally, these things are basically the same. It's just really the formatting of it is now left into the template. So in other words, I can now do something like this dash here, or I could, if I was doing HTML or something like that, I could put in a div in here and so on, right? Of course, I don't need to do that for the Ansible version, but it's just nice to know that you have multiple options on how you're going to format out your templates. And this is the one I typically go for. Okay, cool. So the next thing is, of course, is another instance. So like we said before, you know, what if we needed a load balancer? I'd come in here and just change this one to being LB, like load balancer. The count itself, well, I'm not going to have a count. I'm going to have 0. So this one is going to be dash LB. So this is, of course, still a instance. It's still a virtual machine, but in Ansible, we're going to treat it as a load balancer. This is not a managed load balancer like node balancers from Linode, but you can absolutely provision those instead, and you'd use very similar processes. The documentation's there, and it's really easy to follow, I think. Okay, so everything else I can just leave the same. And so instead of having a multiple count here and trying to split these things up, I just have a whole nother resource for the load balancer. Now, another reason to do this specifically for a load balancer is so that we can change the type at any point if we need to, right? So if we were to need to upgrade the load balancer, you would be able to change it. Now, there's a number of things we'd have to discuss as far as load balancers are concerned, like perhaps you'd have yet another resource that you'd want to change in the meantime so it doesn't affect the production systems. But in this case, we're going to keep things as simple as we can and just use this load balancer. So now what I'll do is my load balancer IP address as an argument. And this, of course, will be our Linode instance dot, and that's going to be Ansible LB, and that should be Linode instance, and then dot IP. Here we go. And we put a comma at the end so that it separates things out. And just whenever in doubt, if you need, you can put this as a string, but I think we'll be okay with how it is right now. Okay, so of course it's going to create a brand new instance. So at the end of the day, our current Terraform project has 4 instances because of the defaults and all that. So now if I go ahead and run this, I get a auto approve here. Looks like our template has a problem. Oh, it's just a spelling error there. Let's fix that. Go ahead and run it again. And there we go. So now we're going to go ahead and just let this finish, and we'll come back and see almost the finished result. Almost. We still have a little bit more to do. Okay, so moment of truth. Well, it's not going to change a whole lot just yet because I didn't actually pass it into the template itself. So I'll go ahead and change this to load balancer as the group. And then we will pass in that argument from here. Great. Once again, we'll auto approve it. And of course, the inventory file changes very fast. And there it is. Great. So of course, the current problem with this inventory file is it's in my Terraform project. I don't want it in my Terraform project. I want it basically anywhere else. So this basically anywhere else, what I'll do is I will actually create a DevOps directory. So I'm going to go ahead and copy this, and we'll call this DevOps dir. And what this will allow us to do is take a look at another kind of built-in function called dir name. And we would just take the local.root dir. So this DevOps directory will then allow me to have other places to output files on my system. And I'm just going to call it DevOps. Cool. So back into, Ansible inventory.tf. We're now going to go ahead and use that as part of my output. And then I also want to change it so it's not just DevOps dir, but rather the Ansible dir, or try IaC Ansible maybe. And that's now where I want it to go. So when we get to the try IaC Ansible course, this process might be different. I just want to let you know about that now, or I might change things about it to fit that course specifically. That's not really the point. The point is, once this is done, this inventory file should go away, and it should be put into this location on my workstation. Now, one of the caveats of this specifically, the actual file name, the location for this, would be to actually turn it into a variable itself. The entire thing. That way, when you actually need to do automations like GitHub Actions or something along those lines, you have the ability to auto-generate that output file somewhere else where it's based off of a variable. But for now, we'll leave it as is. I'm going to go ahead and plan it out first. And what we're going to see here is it's going to force replacement, right? It's going to add one and destroy one as expected with local files. It's going to take this and put it here. Cool. Now, before I even look at that, what I want to do is navigate to the root, and you see that I do have a DevOps folder in my case, right? So I actually tried this out. I'm going to go ahead and remove it. Okay, DevOps folder gone. We'll go back into try IaC Terraform, and I will go ahead and run this plan now. Okay, and I'll do cat of that file name, folder, all of that. What do you know? It's there. So it actually does create that folder for you, but it's not necessarily going to delete it if you remove it, right? So the folder will stay, and we can just navigate to it manually as well. So this folder will stay regardless of if I have an inventory file in here whatsoever. So if I were to change this to not try IaC Ansible, but just Ansible, and let's go ahead and just open up another terminal window so I can quickly Terraform apply auto approve in here without really touching my location on the other one. It changed the location. So if I list things out in here, that try IaC Ansible folder is still there. It didn't delete it, right? Which is maybe good and bad. I don't know. But the point is that we can create folders with this output. Terraform will do that for us. So if you have multiple directories you want to put it in, there you go. It's really straightforward in that front. Now, the other thing about Ansible and Terraform, or, well, mostly Terraform, is this resource itself. You can have other kinds of resources. You could store this in other places, and then both of them could use it in another place. So if you were to want to store it in object storage, for example, or AWS S3 or any other kind of S3 compatible storage, you could do that. You could do that in one of the resources. Now, setting up all the permissions to make all those things happen is outside the scope of this course, but the idea being this Ansible inventory file, or inventory file, would be basically anywhere you would want it to be. And then your other tool, the Ansible tool, would have to be able to connect to that as well. Which I think is important to understand, that Terraform itself doesn't have to output it to a local file. It can be virtually anywhere. And we've seen this with the backend, the state file itself, right? We saw it there, and I just wanted to highlight it for the inventory file because some of you might be like, oh, I don't want to have my Ansible project and my Terraform project running in the same spot. That doesn't make a whole lot of sense. But for these courses, it makes a lot of sense to learn and to build it out. So yeah, that's the Ansible inventory file. That's sort of an end-to-end example. And I mean, the important part about this is to be able to get to a point where you can output your IP addresses to a specific spot. So the output of any sort of Terraform resource, we can change as we see fit to make sure that we are able to accomplish our goals with our infrastructure. And I think we accomplished that with this one, at least for what we set out to do. Hey, thanks so much for watching. Hopefully you got a lot out of this one. I want to leave you with 3 things. The first one being, check out the Terraform docs. I think HashiCorp did a great job giving a lot of different tutorials and use cases for Terraform that are just outside the scope of this course. The next thing is to actually explore the Terraform registry. Terraform can manage a lot of things that aren't in the docs directly. They're not in this course, but the registry has it. There's a lot of services out there that you can provision things with Terraform and an API key, like we did here with Akamai Connected Cloud. And the last thing is, of course, this actual course is made and designed to tee you up for the Try IaC Ansible course. That will allow us to provision and configure our virtual machines to run a very specific way. So for example, installing Nginx and creating a load balancer out of that so we can have a web application running in a load balanced environment. It's actually fantastic, and Ansible makes that really, really easy. And the combination of Terraform and Ansible I think is great because it's incredibly portable and really easy to just turn all of your virtual machines on and then have Ansible configure them the way you need them to be configured. It's fantastic, and it's a great tool. I highly recommend that you check that out next.